Hey there, welcome back to the channel. Today I'm working on a customer project. It is a current sensor, and as a test device, I'm using this heat gun. Now, I've seen some interesting things when testing this, so I figured I'd at least record it and let you see what it is that I'm seeing. So this is a heat gun. If you are unaware what they do, basically I can turn it on and it generates heat and blows it out here at different temperatures. It gets hot enough that it will actually even melt solder. This one has a few different controls. You can see it's got a switch here for low, medium, and high. And then it has basically like a potentiometer here that I can adjust the heat range within that. So I can do low and then adjust it, medium, adjust it, and high and adjust it. One would think that it just has some sort of a resistive coil up here that it puts voltage on, which heats up the air as it passes through. And my original assumption was that this switch simply changed the voltage that was going to this, and maybe this rheostat was in line, so it was just all analog. When I started looking at the signal that came out of this, both with the sensor that I have and the oscilloscope, it's actually really interesting, and that's why I wanted to show this to you. The first thing I want to do is we want to get a baseline and just take a look at the current flowing through this with a current meter. This meter is doing what's called RMS. You can kind of think of it as an average. Its root means square, but it is taking the average of the current. It's using a current transducer here. This is the live wire that goes over to the heat gun, and so this is just going to give us amps out here. So if I take the gun and let me just turn this all the way to highest, and if I turn it on low, you can see it's about 600 milliamps. Medium, 6.3 amps, 6.4, and high, we've got 11.6. Now, just because I don't know how the sound will be on this, what I'll do is I'll turn it on and I'm going to sweep through these numbers here on one of the settings, just so you can see that it adjusts that current flow over here on the meter. So I'll go to medium and then I'll sweep through those. You can see it's at 6.4. But if I adjust this, it comes down. And in fact, the low here is the same as the low setting here, even on high. In fact, low, this does absolutely nothing. So let's go take a look at an oscilloscope hooked to this same line and look at what that looks like. It's a bit messy here, but I've got this current sensor board, which actually has two sensors on it connected to each one of these outlets. And then we've got an analog port that comes out. Right now, I'm using this just to power this device so that it has 3.3 volts to charge up those two sensors, and those two sensors are coming from these. A little bit easier to see is this. So we've got two sensors. These are TLI 4971 current sensors. So basically, we have current comes across here in AC. This current sensor turns that into an analog voltage, and then that analog voltage comes out here, and this is what I have the oscilloscope connected to. So let's go take a look at the scope when I run this, which is the heat gun. So if I just put the heat gun on to low, take a look at this waveform. I'm going to move the heat gun so it's not making so much noise. Actually, I'll just capture this. And let's zoom in on that a little bit. And let me recapture. So you can see we don't have a constant current coming out of this. It's turning on, then shutting back off and turning on. This low voltage here is the reference voltage for that A to D. So it's going positive current for a bit and then coming back to basically nothing. So really, it's just pulsing on and off in order to get heat.
It's not staying on all the time at some voltage. It's coming on to to some set voltage here and staying constant and then shutting back off. It gets more interesting when we go to the medium and high heat ranges. So let's take a look at when I go to medium with this turned all the way up. So you can see it's doing the same thing, except here's low and here's medium. So this peak, instead of clipping here, comes all the way up and back down. So we basically have this consistent pulse that comes across here. And again, this is on the maximum range here. Watch what happens when I adjust this though. You can see it doesn't adjust the height of these, it's just skipping a bunch of them. So if I drive it all the way down to minimum, here's the waveform, and here's low. Identical. So low here on the switch is the same as medium with the lowest heat range setting. And then as I turn it, now we get one more. We get a couple more. And so as I turn it, it basically is just filling in some of these peaks that are going all the way to high until I get to there. Now let's take a look at the high range. Remember, this low point here is the reference voltage. So these are all positive voltage spikes. Now if I go to high, it actually goes from positive to negative. So here's medium, here's high. So it's cycling through the entire wave, but it does the same thing here when I turn this down, is it starts clipping them and they're either not going high or low. If I crank this all the way down to there, it's about the same as medium. Actually, it's not even the same as medium, right? So here's medium all the way up, and here's high all the way down. So it's kind of interesting. Instead of giving us some sort of a constant current draw to basically give us heat, it's giving us pulse behavior, and it's either adjusting the height of those pulses and it's also adjusting the number of pulses that it's giving in order to adjust that heat output from the gun. So one last thing, let's go take a look at the output of that sensor itself into a microcontroller. It should look, again, identical to this because we're just hooked up to the output right now. And so if we have an A to D on a microcontroller and then we display that, let's take a look at what that looks like.
Okay, so I've taken the wires that were going to the oscilloscope off, and I've added this wire over to this meadow. Basically, it's just power, ground, and then 2 analog, so we're only reading one of them, and it's printing them out, effectively acting as an oscilloscope, but this one is running in .NET, so this is a C# application that is drawing this. Right now, the line is up at the top. This is our reference voltage, but if I turn on the heat gun, those values should look just the same as the trace that we saw on the oscilloscope. So if I go to low, you can see basically the same kind of thing. If I go up to medium and I adjust that temperature down and back up, and then if I go to high and again adjust it down and back up. So you can see we get the exact same waveform here on this device that we saw on the oscilloscope. So that's all I've got for today. Hopefully you found it at least a little bit interesting. If you like this kind of content, go ahead and leave a comment down below. Otherwise, remember, if you've got an idea, you can go out and make it.